Oh, you don't need to go live for this. Only for the session.
Ah,
This is only for now. I'm sharing my screen now.
okay.
It's like this thing,
Yeah, yeah.
and it goes like about this thing, about this.
How much is that? 318? What?
This is
Dollars?
16.
$16. Yeah, got that.
Okay. And the reason you didn't buy another fuse is it the cost?
It's because it wasn't working anyway with the fuse also.
Ah,
We
you
didn't.
bought the fuse.
No, we didn't. We didn't buy the fuse because we don't know exactly how to run it properly.
Okay. So now the the it has the fuse in the machine.
There is
No.
only one of the fuses blue. There are two more like this.
Ah, there are two more like this.
Yeah, and they're not
So
replacement.
okay.
They are as a part of the machine.
Okay. Three more. So maybe it's one per phase or what? Or different parts of the machine.
Yeah, maybe that's the reason.
Okay. So you got a fuse like this and you install the fuse
Yeah.
and still it's not working.
No, no, we haven't got. Since we don't know what's the problem and the fuse also blew out, we didn't invest more time in it.
Okay. So uh, we need to know what were you doing, what was happening. It was a storm. Was why the fuse blew?
Hmm.
Why was that? What was it? Were you there or
No, Vinod was there. I wasn't there.
Vinod was there?
Yeah.
It happened during the running of the machine.
Yes.
Okay. Because if the problem is something accidental, you just replace the fuse, you run the machine again. It's no big deal. But the problem is that if there is something internal in the machine like frost, now you replace the fuse, it's gonna blow the fuse again.
Yeah.
So we need to know this. Is we not over there?
No, he's not here right now.
Can you give him a local call because he know we are talking about this?
Yeah. Hang on.
I want you to ask him if he was there when the fuse blew
Hmm.
and what was happening. It was a storm or
Okay.
any clue that can give us if it's accidental or internal of the machine. I mean external or internal.
Yeah. Hey Vinod, Puneet here. Yeah, so Frank and me are discussing about the compressor. So he wants to know certain things about when the fuse blew, how it blew, and the conditions, how it happened. Uh, would it be possible for you to join the Hangout in a while? Yeah, you can. And how much time? Hello? Yeah, Frank, I think he'll join the Hangout in a while.
Okay.
From the talk I had with him earlier about this, he told he was running that machine, and then while the machine was running, it just blew. It stopped running, and then they found out that the fuse is not working.
While running the machine.
Yeah.
Okay.
I'll also get the manual. Just search for it. Okay.
I will not.
So
Not. Hello. He's mute. I think. Is he mute?
yeah, I found a page here which says it is 115 volts, 60 hertz, single phase.
The single phase,
Yeah, it's a single
50 or 60 hertz?
60 hertz, 115 volts,
100?
115.
So it must run with a
Transformer.
transformer.
Actually, I'm not sure. Like, I have to check this out properly. There's also another three-phase here. Positional data neutral.
Not.
Yes. Good morning.
Hi.
Hi.
Hi. Do you remember if this machine was running with a transformer or without a transformer?
Without a transformer.
Without?
Yeah.
So it doesn't need a transformer.
Yeah, that's don't need the transformer. It's 230 volts.
Okay. So Punit says that one of the fuses blew. A fuse like this one.
Yeah, same as.
Something like this. So why didn't you try to replace the fuse and see if it was working?
Yeah, it's actually the fuse is like 2000 rupees. Uh, we don't try to change the fuse because in internal any issues in the circuit board something that fuse again blown.
This costs like this, about this amount in India.
Yeah, it's 2500. I search with the online market. I just get the values 2000 something, 2500 of.
Okay. So you are not replacing it because you are afraid of this happening again and wasting the money, isn't it?
Francis, it's the first mission we start to
Wait,
run. Hello.
wait. I have a lot of noise from somewhere.
Okay.
Maybe you can you understand, Vinod?
Yeah.
Punit?
Yeah.
Do you hear correctly, Vinod?
Yes.
Uh,
Yeah. I heard.
yeah. I don't think you can avoid
Okay.
it.
Vinod, again, please.
Yes.
Yes. Um, I mean, Vinod. Okay, let's go again to the beginning. Uh,
Okay.
when this happened, the machine was running when the fuse blew.
Yeah. It's actually the machine running. It's three of 2 minutes maximum.
What?
2 minutes. 2 minutes.
2 minutes.
Yeah.
Yeah, but this is
Then the fuse is gone. It's not work.
Okay. I mean, we are trying to guess if it was an external thing or internal thing. Because if it was an external thing, the fuse protected the machine,
Mhm.
and then you replace the fuse and everything is normal again.
Mhm.
But if this was something internal in the machine,
Mhm.
the fuse was blown from inside. Doesn't matter if you replace the fuse, it will blow again when
Mhm.
you as soon as you start it.
Mhm.
So what were the conditions about running the machine? It was like, I don't know. What were you doing? Like with the sandblaster or
I think they were running it without any load.
Yeah. Yes.
sorry, running?
They were just running it without any load. Just get the
Just
machine.
compressing air.
Yeah. Just start the machine. That's all.
I know. Easy. Here there are two inputs.
But I think without trying uh, to put another fuse, we will not know if the machine is internally crossed.
Mhm.
Yeah.
Okay.
But
there is inside the machine there is three fuses are there. There is one fuse is gone.
Oh, you your audio level is very low. I barely can hear you.
Uh, can you hear me
Now better.
now?
Yeah, better now.
Okay. Actually, the machine have three fuse inside the system. It's
Yes.
there is one fuse is gone.
Yes, Puneet told me. Maybe it's because this is a three-phase machine.
Yeah, it's not a three-phase machine. It's just there's mentioned it's a single-phase machine.
It's a
There is
single phase.
yeah, it's a single-phase machine. We gave the 34 ampere power input, 32 ampere power we give to that machine. It's a single phase.
Yes.
So it's not work. First time we start the machine, it's automatically trip down.
Automatically what?
Trip
Drift? What is that? Can
trip
you type?
means
Circuit breaker.
What?
Break. Breaker.
Can you type this? Your echo cancellation circuit is canceling something.
trip means if the power load is high, the switch automatically turn off.
The surge of the electrical installation, you mean? Ah, the surge protector. Of what? Of the machine? Or the place? What surge protector?
And one more thing, we try to an electrical man. They have to come and see the machine. He said it's an imported machine, so inside the board have some problems. That's that thing. So we connect the compressor company and what's the problem in the machine.
Ah, the surge protector inside the socket.
So Frank,
Yes?
is for each power, like a high load socket. Then we have individual surge protector for each of, and then there will be surge protector for boom or for an AC machines like this.
Okay. Then
Surge.
the surge protector, how many amperes is it?
It's 32.
It's 32 amperes.
Yeah,
Surge protector. And the
yeah.
machine
We
rating?
we have two such protector. One is the main thing. Main is say it's 40 something, and machine connected 32 ampere.
Okay. And the machine rating in power is how much amperes?
23 or something. 23 about.
23. So if the surge run is because the machine was drawing too much current.
Mm-hmm.
So it has an internal cross, not something external. The
Mm-hmm.
machine has an internal cross.
Yes.
So if you replace the fuse, it will blow again.
Yes. Same as.
Okay.
We so we don't try that.
Okay. Is there something that you can see in the board that is internally burned or something like this? Or blue apart from the fuse?
I don't get it.
Yeah, I mean, if you look at the machine,
Mm-hmm.
you say like You say like this is the board, okay,
Yes.
with all the components. And this is the three fuses, say.
Yeah, three phase.
One you showed it was broken, blown. But this electrical man, I mean, I haven't seen this board. It's like, uh, I mean, like an very electronic. It's a basic board for power supply, or it's a power supply, or it should be only a power supply, isn't it?
Mm-hmm.
But is it or not?
I think it's a phase fuse.
Phase fuse? What is
Yeah.
that?
It's actually a single phase machine, but inside it's three phase. It's convert to three phase. That's the three fuses.
You mean it gets a one phase here and converts
Yeah.
it through three phase here.
Yeah, same as.
Okay, and then it has something for the machine, for the compressor.
Yes.
So the electrical man came here and said something was wrong inside here.
Yeah, something was wrong inside the machine. So they connect first to they connect it's 32 ampere switch, and it's tripped, and second they connect to 42 ampere, that's also tripped. The electrical man says it's not the electrical issue. So we connect the compressor company, and we can check the problem for the compressor.
You contacted the compressor company?
No, I just next I contact with Francis and just give a mail for this machine is not working. Uh, your objection, you give an objection for that.
This is when you contact me.
Yeah, yeah.
Okay. So this happened like a few days ago.
Yeah, it's the prefab academy is going on that time. We buy the pipe and something, uh, the pipe and knobs, and we connect the compressor and sandblaster, but we start to the compressor after 1 month.
Okay. So one thing we note, this is the
Yeah.
compressor,
Okay.
and it has this electrical board,
Yeah.
and the man the man said that there is something wrong in this board or in this compressor.
This compressor inside the there is a control board is there.
So there are more boards than this one.
No, Francis, you just drawing that's a outside board, yeah.
Yeah,
Yeah.
I'm drawing it outside, but I know it's
Outside.
inside. But I want to know if the man said it's an electrical problem of this board or a mechanical board problem that is making
No,
this board.
no. That the electrical guys say the compressor inside there is a control board is there.
This one.
Yeah, this one. Yeah.
No, other than
Pardon?
a board to control the motor, our that should be a board. So I think he's talking about that.
Yeah, this control board. There is
No.
only one board inside, isn't it?
No,
There is so many boards are there.
They should go
There
to.
are many boards.
Yeah.
Yeah. This is just the power conversion. And
Can you take a picture of the boards
yeah,
inside?
we can do that.
Are all of them together?
Sorry.
Okay, but in short, the man said that the problem was with this board
Not this
or
exactly.
with or didn't or couldn't be able to isolate which of the boards was the problem.
Yeah, I think that's the thing. We couldn't isolate, or we haven't tried to isolate which board the problem lies with.
Okay, you don't see any external bond parts that can give a clue where is the problem,
Uh,
apart from the broken fuse.
I personally haven't checked it, so I can't comment.
Okay, if you could check, so then I can write the Fab Foundation and tell them I'm sure that there is a problem with this board
Mm.
or
Right. Okay. I'll make something detailed.
Yes.
yes, because if they need to send a replacement
Yes.
and this is not the correct replacement, then we waste our time. If we
Yes.
can guess what's happening, is the best.
Okay.
So take a picture of how many boards are there? Many boards, you say?
Many boards. Yeah.
There is three or four boxes.
3 or 4. Okay. Okay, so yes, take a picture
We'll do that.
and I will contact Fab Foundation. Okay. So now let's go to the topic we were talking today. Um, let's see. We were talking about this thing today. When you mill the foam, okay, this is going to be your block of foam. You are going to do some volume here. Then there is people. I think someone has to mute, maybe Vinod or something. That you? So there is people who just places the fabric in here and they apply the vacuum or the close tool, and this will end up with many ripples because this cloth is gonna make a lot of ripples because this flat thing cannot adapt because this is not elastic. This cannot adapt to your surface. So when you try to apply this, I mean, you can try. If you try to apply a flat cloth, I mean, to say you mill a block, around a block, you will see, you will create ripples here because it's impossible to pack this inside this correctly. Okay. So what we want now is to cut a precise piece of fabric so that it will adapt perfectly to your surface. So there are many ways to do that. One way is SolidWorks. SolidWorks, I haven't tried, but SolidWorks has tools for that. I mean, if you Google for things like unfold, unwrap, these are the keywords. Develop a surface. Also, Rhino has some tools like Squish. I think. I mean, you test if you have Rhino. There are some tools that they can make surface like flat. Also, SolidWorks has it, and Inventor also has some tools. Okay, so you try this, and you can do this as well. But I'm gonna tell you now the basic principles. How are they doing this? Say we have something simple, like a mechanical, so I mean like a block or something like polyhedral. Then the only thing you have to do is unfold. Okay, you unfold this surface. You unfold this surface, and you will end up with something like this. So you will cut 2 times this with the laser, and when you apply this with resin on top of your surface, this will wrap perfectly. Okay. One thing you can do is in these seams there will be no clothes, so this will be a weak thing. So you could also develop this you could develop this like having a seam here and develop the surface. Okay, so for covering these seams at the corner. So you don't want any seam with only resin here. So you want another layer of cloth covering these seams. So you could have 2 of these, one on top of the other, and another one covering the surface. This is the theoretical. This is what you would do for something like polyhedral, something like this. Then, let's say you have a cone. Let's say you have some conical surface. What you need to do is unwrap. So this, a cone has, if you develop a cone, it will become something like this, like a piece of a sector of a circle. So this length will be this length, and this will become this radius. And if you have a trunk of a cone, this will be like this. Okay, this is the way that you unfold this. And if you Google this, there are, you will find ways to do this, to tell you what is this angle that you have to unfold for this length. Okay. Then a sphere. There are many ways to unfold a sphere. Like if you cut from the equator, this is a meridian. This is another meridian. Okay. If you have your globe in meridians and you unfold it, you unfold it from the equator, you will end up having something like this. This is the equator line. Many of these. So the more you have, the more precise will be the sphere that forms later. Okay? And this will be, I mean, let me paint it together. What I'm painting in blue will be together. Will be this line only. Okay, this is the way that you unfold the surface. These are for simple things, like there is a full mathematic sector that is talking about this, and not all the surface can be unfolded. I mean, there are developable surfaces, there are not developable surfaces. When you have something that cannot be developed, you need to do a lot. You will end up having something that in the end is impractical. Say you have a mountain, something like very complex. I mean, this is not practical to unfold. Because even if you find the software that can unfold that, it will have so many cuts, seams, that it will be impractical to place this surface back to this mold and making all the seams work together. So if you have this kind of surface that is not practical to develop it and make it a surface, what I recommend you is just place the thing on top of this, and there will be many ripples, but there's nothing you can do about that, because even if you find a way even if you find a way to put this in here, it will not be possible to put it back. It will be very difficult surface. So this is about unfolding. Now let's talk about bias. So let me find the correct address. Something like this. You see this dress here? Okay. So how do they do for the dress to adapt to the woman? So this is because if you look at the fibers, if you take a piece of cloth, and you look at the microscope, the USB microscope that you have in the lab, you will see that it's made with fibers like this. So if you try to wrap this into something like this shape, like a woman shape, it will not adapt. There will be a lot of ripples everywhere. So what they are doing is they are cutting the clothes at bias. This is what they call a bias cut. So when you try to wrap this around this body, there will be no what do you call rings? My English. Hold a second.
Wrinkles. Yeah.
Wrinkles. You call them wrinkles.
Wrinkles, yes. Sorry. Yeah. No wrinkles, and this will have wrinkles. So you have to take this into account when you are wrapping fibers around a body that is curved like this. So if the body has a vertical axis, okay, you want the fibers to be like this. You don't want the fibers to be like this, okay, because this will bend, the fibers will bend and adapt to the surface. This will not, will create ripples. So take this into account when you cut this in, when you do this to your fibers. If this is not flexible, then you need to use bias cuts. Then another thing is strength. They also do something regarding, doesn't matter about this, but say you have a simple thing like a cylinder. If you place the first layer like this, you should place the second layer of fibers like this. Okay, so the first layer like this, so you have resistance in this direction. Okay, in tension, your body is resisting this tension. But if the second layer you put it like this, like bias, you also have resistance in this direction. And of course, if you have more layers, you could have more angles and you could have like more resistance. But with two layers, you achieve resistance in many angles already. So this will be a very strong, stronger material if you just apply one layer like this and the second layer again like this. Okay. So then another thing to take into account when you place your mold is that say you make a sphere and I'm having the mold like this, like from the side. Okay. So your mold should be in such a way that if you place the cloth here, should be a gap here and a gap here. This shouldn't touch the bottom. of the mold. This you shouldn't, because the resin is going to go from inside to outside, and if you put it like this, the resin is going to accumulate here, and you will end up with a bad finish here in the border. This will have bad finish, and if you do like this, this will be a clean cut. It doesn't mean you will not need to sand it, but this will be a huge, like if you have your shell something like this, like I had, this was the problem that I had. It was very nice, everything was very nice, except for this border that has a huge blob of resin. Everything was a huge blob. And it's very difficult to fix, you have to just cut it. If you do like this, your fibers, I mean, you have the fibers like this, maybe you need to sand this a little bit, but there will be no blobs or accumulating here of resin. So this is another advice that I give you. If to fix this, what I recommend you is when you create your mold, say if your mold is going to be something like this, like a cylinder or whatever you are creating, at the end you extend it a little bit by 1 or 2 centimeters, and then you place the base. Okay, so your part is only this green thing. This is your fabric. So when you apply vacuum, you allow enough space from your fabric to the base to allow the resin to flow. Okay. Then, now I think, did we calculate the volume? Yes. Resin. So you allow to cure this. When you pull vacuum here, you have to leave this overnight. Meaning we have only 6 nights. So at least 2 students, you should be putting this in groups of 2 at least to be able to achieve this on time. Okay. It doesn't matter if you finish on time. Remember that you have to. Okay. I think I have some polysons here. You have to define a solid, then to mill the mold, then you have to cut the fabric, then you have to calculate the volume of resin, and you have to dip the fabric, apply into the mold, and then vacuum. So these are all the steps you need to do this week. So these are actually the ones that you are actually making the composite. But even if you don't reach that that stage, you can arrive to this part. So I want you to make all your pages and start putting all these things you are going to do. Even if you don't dip this into the resin, if you don't dip the fabric into the resin, if you don't apply this in top of the mold, even if you don't pull vacuum and then you obtain the result, even that I want you to do like this. So now your page, your page. I want your page to reflect all of this.
Frank.
Yes.
So let me. So for we have to put that food film first, and then the resin, and then the fabric which is dipped in resin, right? Because that will act
No.
okay, then if we are putting the cloth directly on the mold.
No, sorry. This was correct. Sorry. First you apply film.
Right.
To isolate the mold from whatever you put.
Yeah. Yeah.
And then you put the fabric that is already dipped in resin. It's not resin and then fabric.
Yeah.
You dip the fabric in the resin and you squeeze it and you place it carefully in the mold, on top of the mold. It's not that you put fabric and then you paint it or something like this, or you pour resin. You already place the fabric with the resin already. Like the method we are using.
Yeah.
There are other methods that you apply the fabric dry, and there is like an infusion of resin. But we are not doing this. So, what was the question, Punit?
Just getting just getting a clarification of that. It's okay.
Okay. Let's me put it again. So you put a film, okay? Then you put one layer of fabric. One. Another layer of fabric. Or many more if you want. Whatever you are doing. Then you put we put another layer of film. Then we put what is called the breezer. Is it like this? This is the basic set, and then you put the back. You put all of this sandwich inside the back.
It's breather, like breathing, breather.
Like this.
Yeah. Yeah. Where does the bleeder go?
Sorry?
Bleeder. There is a film with holes.
Yeah, this is the basic set. Okay? With this set, the resin can only go this way. Okay, because this is impervious. This is impervious. So the resin can only go this way. So the other is this let's paint it blue. This film with holes. You place this when you want the resin to go through these holes like this. And you can put it in every pair you want. Like if you want the resin to leave from here, not from here because we have this, but if you want the resin to go from here, you replace this with this, and the resin will also go like this. But it is depending on your surface. Meaning, say you have with this set that I told you, the only way for the resin to go out is this way and this way, from the ends. Like if you have something like this, the resin will leave only from, what I'm going to paint you, from, oh no, not contrast enough. Resin will leave from this, from the corners. So all the resin will leave like these directions. But if you have something, some shape that you know, something like this, that you know that the resin here will not make all the way down to the exit because it's very long way, and if you do like this you will dry everything, then you put this on top of this, and then your resin will leave from everywhere. You understand the difference? The resin will leave from everywhere. This is the difference. Okay?
At that. So about the.
So now, about the what is the hangout?
The material, the foam.
About the foam, yeah.
Yeah. So Nisha was suggesting she will get a expanding foam, so that can be used, right?
I mean, that can be used. I mean, you only need a soft material to mill. Okay? Something that is soft. To mill it quickly. The only problem with the material that Nisha was suggesting is that this material, okay, something darker. This material that Nisha was suggesting has voids on it, air voids. So when you are going to mill this, instead of having a surface like this, you are going to have a surface like this.
All the insulation foams are like this.
This is one thing that you are going to happen.
Voids, polyurethane. All the polyurethane foams are like this one. But it won't be like thermocol.
Yeah, this is one of the problems. The second problem that you are going to have is that with the high density foam, you try to press it and it's so dense that it's very difficult to bend it and to make something, to compress it. With this resin, it's kind of soft. So when you are going to apply vacuum, the whole thing is going to deform. And you don't know how it's going to deform, right? The final shape, you don't know. It's like random. So you will not have the shape that you want. These are the two only limitations of this. So, okay. I mean, this is cheap, the high density foam, so from construction. So with one plank, I think you can, one or two planks you can fit all students for the assignment.
Yeah.
And it should be like a couple of US dollars, one of each plank, no more than this.
Yeah, not sure we will get this, high quality, high density foam. It's not used much. The high density polyurethane foam probably we can try. Polyurethane foam will have that void, like the one Nisha was suggesting.
Yeah, this foam expands in volume when you apply this. Is like they also sell it here in spray for sealing like voids or whatever.
Yeah, yeah.
It expands, and when it dries, it's kind of hard, but still, if you press it even with your finger, it can press.
Yeah, I know that.
And if you try to mill or carve it, you will see that is it's not very it's not very it's not very I don't know, the finish of the surface is not very
Okay. Yeah.
but regarding the finish of the material, I mean, if these voids are small, when you apply the fabric here, like the fabric is not going to do like this. The fabric is not going to adapt to all the voids, because actually the fabric
Yeah, the voids also won't be exaggerated. It'll be very.
sorry?
The voids also won't be that exaggerated. It'll be small, very tiny. Right?
Yeah, I'm making them exaggerated like for you to see. They won't be like this. I know. And also, but even if they were like this, the fabric will not, because it is not very elastic. It maybe will bend a little bit, but not too much. And if the voids are small enough, it will pass over. It will even bend. So I mean, when you are milling your foam, doesn't matter. It doesn't matter that it has a high quality surface finish, because the fabric it will not replicate this. So just mill it at full speed and don't care about the quality of the surface. If you want to sand it because you are very specific and you want it perfect, you can sand it, but the fabric will not replicate, especially if you are using burlap. If you are using finer cloth with finer fibers, then maybe can replicate some of the smell imperfections, but not really. Now, Puneet,
Yeah.
me,
Now, another thing which we can do is maybe coat this mold with epoxy resin, and that can probably give a good finish if someone wants a good finish.
yeah, I mean the film already gives it a good finish.
Yeah.
And remember, the film or the film with holes. What is the name of the film with holes?
Bleeder.
Bleeders. If you put bleeders or film, this is gonna be part of your composite forever. There is no way to remove it.
So even if it is abrasive, it can stick, and you can forget about it.
No way at all. But then after you finish and your part is already hardened, you can apply a clear coat of epoxy resin with a brush or something, and this will give you a crystal look surface, like a very shiny surface. Depending on the goal of your product. When I did mine, I liked the sort of matte look. Was not matte but satin. I liked the satin look. And then if you want a matte look, you can also use the sandblaster that is not working to do that. So I think this is it for today, except for did you already decide, all of you, what is your parts you are going to make?
Yeah, I was thinking of making something. I think it was uh, surface generator or something I found. So I'll be using that to generate some surfaces and then use that.
Okay, when are you thinking of having the foam?
Foam.
Yeah.
Not sure.
Okay. Suhas, are you there? Are you connected?
I think he's trying to speak, but nothing is coming.
Probably. Well, so if you can hear me, Suhas, if your students they haven't decided so far what surface they want to do, just assign them I don't know, a parabolic hyperboloid, a cone, something with two-sided curvature. Don't do a one-sided curvature because it's very easy.
Hello,
Or if you
Francisco.
want, yes, Prasan? Hello?
Suhas want to speak with you.
Okay.
Yeah, 1 minute.
Hello.
Suhas,
Yes.
please, one thing, if your students haven't decided a surface to do for composites, just assign
Okay.
them a double-sided curvature, any double-sided curvature surface, like a sphere,
Okay.
like not a
Actually,
cylinder.
actually,
Yes?
yes. Actually, Prashant did his composite assignment,
Mm-hmm.
and Surprise is deciding to make a helmet using a natural fibers, protective helmet.
Okay. Okay, but there is a warning with all of this, because I saw that
Yeah.
for molding and casting, Russian was using
Yeah.
an already existing object as a mold. This is not allowed.
Okay.
You cannot
Okay.
use an
Okay.
existing object as a mold. You have to mill a 3D mold.
So he have to show some design part also, no?
Yeah, you have to show a
Yeah.
design. This assignment should have a design part. That you design an object, then
Okay.
you mill the mold, and then you do all
Yeah.
the manual things about the making the composites. You
Okay.
cannot
Okay.
place like the composites on an existing surface. This is not allowed.
Okay. Okay. I will tell him. Yeah.
Okay, this is a common source of for the evaluators to mark this assignment as incomplete is because you didn't design and mill your mold. You apply this to an existing surface. This is not allowed. Or it's only valid towards the second part of the assignment, which is the part where you place this and make the vacuum, but not for the first one. You still need to apply.
But during his lecture, he wasn't too keen on design of the mold. He was keen about how the composites come out and different materials and then such things. I think he specifically
Yeah,
told to design it, but the assignment is slightly different from what he says. The assignment asked us to design it. Neil didn't tell that in Neil told it in a different manner during his lecture. So that might be a confusion for some people.
yeah, there might be a confusion because then when the evaluation comes, they don't do it like this. They will, I mean, again, look at this is one part, and this is another part. If you apply this to an existing object, you have this clear. But you still have to do this, design and make a 3D mold about a square feet, which is 30 centimeters side. So don't miss that part. In this, every word counts. So it's design, is meaning design, like with 2D design or 3D design software, whatever design it is, and also fabricate this mold, mill this mold. Okay. There are also some people who are making a mold not with milling, but with a press fit, some sort of assembly. Like they do something like this. This is also considered as valid. You make, you make this sort of surface that you have this thing like this, and then orthogonal something like this, like a press fit thing like this, and then you apply cloth on top of this. This is also valid. Like if you are making a kayak, you don't mill the hull, the hull. You mill like only, you only put like the, I don't know whether know the name of this in English. But this is the structure. Okay. This is also valid, but applying to an existing object, not valid, for sure. Okay. So, okay, let's see. I'm gonna check your pages, and remember that since I am remote instructor and not local instructor, I can only see what you share. So if you don't share anything until the last day, I don't see anything. I cannot tell you you are doing something wrong. You could do something better. If you don't share what you are doing, I cannot help you. So you are working like alone, which I don't recommend, because then you will learn very little. Better that you share what you are doing, and the people will see and will talk and all of this. Okay. So in a week, I'm reaching now Mumbai. So let's see what we have till there. solve.
Frank,
Yes.
what are the natural fibers we can get? I mean, no, I'm not saying natural. The textile industry fibers we can get, like nylon, polyester, cotton. Which one do you recommend?
I
Any?
would recommend like natural fibers, but you can get any. You can use any.
Okay, so
Like,
what about the strength and all those things? I mean, have you tested any? Or
I have only tested like with natural fibers,
okay,
but I mean you can use some other artificial fabrics, but I don't know how will they react with the epoxy. If
okay.
the
So
epoxy will react with them or
you are concerned about the sticking, whether the epoxy will stick to the fiber or not.
no, I mean the epoxy will stick to the fiber. I mean it will wrap, like will be around all the fibers.
Okay,
So it doesn't matter if it doesn't stick. Like, just being around the fibers is just okay. The only thing that the fiber should not be impervious, like should allow the flow
okay,
of resin around it. Like should resin could be able to go through the fiber.
okay,
It's the only, but you can use whatever fiber you want. We use natural fibers because then you can laser cut them.
okay.
With artificial fibers, I don't know.
But
Maybe you can,
anyway,
maybe you
whether we
cannot.
use natural fibers or not, the matrix material is some kind of epoxy, something not natural, right? So does it really matter if we use natural or not? Because after all, we are cutting something unnatural also, like epoxy or polyester.
I mean, you can use whatever natural or not natural, but I recommend you that you use natural and
Okay,
you create natural things.
okay,
Maybe epoxy is not natural, but maybe in the future you can replace it with another
yeah,
kind of of fiber. I mean, carbon fiber is very expensive.
yeah,
But I tell you that with burlap, this burlap thing, I mean, it's not carbon fiber, but you can make really, really strong parts
yes,
with this,
yes,
with burlap. So,
yeah.
I mean,
Carbon fiber or
you
Kevlar
don't
can
need,
cheaper.
yes, you don't need like something like very uh, high tech and something that you don't have there to do some strong parts. Like you can get very nice parts with this burlap. And also what you could make, if you don't know what to do, is you could make a parabolic antenna or something like this. This is a good assignment for this week. That you make a parabolic antenna for whatever signal,
Yeah,
or for a solar outlet, or for whatever.
yeah.
Okay, please update your pages so I can see what you are doing and I can, or at least if you are not showing, explain what you want to do so I can see. Okay? Because otherwise I don't see anything. I cannot read your minds so far. So see you around. Okay, guys?
Bye.
Bye.